Okay, so the last part here is how to generate synthetic values for sensitive variables. We know that generating synthetic data is no different from making predictions of future values, right? At the end of the day, we're doing posterior predictive. So if, just refresh your memory, if you try to predict future log income, we use y tilde I for CUI with its, or given is log expenditure xi, which is given to you. You know that this equation, which is actually just a sampling model, but we add the tilde here because we're generating predicted values of y, okay? But it's no different from what we had before in the sampling model itself. But you know that here, beta 0, beta 1, and sigma, they are like we saved parameter draws for them. So when we do this normal draw soon for y tilde I, we're going to use the draws for beta 0, beta 1, and sigma. Okay, and we're going to use them as a triplet one at a time. Because at one iteration, we have one draw for beta 0, one draw for beta 1, and one draw for sigma. So we use all of them into this particular prediction process and then generate one value of y tilde I. Make sense? All right, so this part should be okay. So this is when I'm saying that this, I think, actually goes back to the question that Maggie asked last time, that, well, how many draws we should do when we're doing all of this, right? So let's just think about our goal. At least the first step is to get one set of synthetic data. And what we mean by that is, let's say this was the data frame, right? We have about 1,000 observations, and we have 4 columns for the original data, right? And we're saying that we're only gonna synthesize one, I forgot which one, but let's just say number 2 over here, which is the income, right? So we're gonna have everything else unchanged. Expenditure, urban-rural status, as well as race category, right? We don't change them, but we're only synthesizing this. So what that means is for every record, every yi, I need a yi tilde, right? So what that means is, so you will see that if you go back to what we did in 347, we had some kind of similar diagram here, but back then it was not about for each record. Back then we're just talking about how you can generate a bunch of simulated predictions for one record and then compare how that is doing for with the original when you're doing those posterior predictive checks. But for synthetic data generation, I want to draw your attention to this because at the end of the day, we want one copy of synthetic data. And then that means for every row, which means for every yi is the truth. Yi is the one that we want to replace with synthetic data, okay? So we have all of the other variables unchanged. So we're essentially only replacing this column. And when we're doing that, you can think about, well, for the first observation, if I want to get y1, so it's y1 tilde, which is what I'm doing over here. If I want to get that, I should first get a mu1, right, which is from beta 0 plus beta 1 times x1, which will give you, so I use y1 here, but it's really just mu1, which is mu1 star, I should say. We get the simulated mu1 star, and then from there we can use the sampling model, which is normal, and then don't forget you have the draw for sigma as well at that iteration. So you are doing that for all of the observations. That's what this table or diagram is about. Okay? So, well, you can imagine what you're going to do. You might write a loop to do it one by one, but I think there is a way. In R, you can just write it as one line, and then it's going to operate on the vector instead of doing a loop. Okay, make sense? So my question for you, maybe just really quick, is, let me see. Are all of this beta 0 the same? And beta 1s and the sigmas? Or they are from different iterations? So I got two answers saying that different iterations. What do others think? Yeah, sorry, I think I'm going a little bit too fast here. Let me just take a step back here. I'm saying that we're trying to get one copy of synthetic data set, right? At the end of the day, we want to replace yi with y tilde I for every observation. I goes from 1 to 1,000, something like that. And my question for you here is that, well, I list the process of what you can do for each observation, say y1. You generate its mu from the beta 0, beta 1, and given x1. And then from there, you can use the sampling model to do a prediction. Okay. My question for you is, am I using the same beta 0 for all of the observations? I mean, same beta 0, same beta 1, and same sigma for all of the observations at one iteration? Or should I do it across different iterations? Let me pause here, and you can discuss with your neighbors to see what you think. And Isaac, you can join anytime. You can just speak up. I'll be here listening. Yeah, let me just jump in. Let me not jumping to answer the question, but earlier Sarah and Maggie were just saying that, yeah, if it's from one iteration, what's the point of saving them 5,000 times in the first place? So I'm just going to add that to the discussion. So take your time. What do y'all think? There are many things like here, like maybe a little bit confusing, but just think it through. Like when we are trying to generate one copy of synthetic data, what are we actually doing and what are we supposed to do? Yeah, what do you think? I mean, usually I think I'm careful enough to keep the index correct. So if I read this, I think I didn't make a mistake. But let's hear from like all of you. What do you think? I mean, well, this really like touches on like in practice when we're trying to synthesize what we're actually doing, right? Are we like getting all of them? Like say, we do have 5,000 calls for all of them. So I'm just asking for one synthetic data set, meaning that I'm replacing the yi with y tilde I for every observation. And that's what this is doing, right? I mean, each row is corresponding for a particular observation. So at that section of the synthetic data generation process, what should I just go ahead? Yeah, go ahead.
I have to run real quick.
Oh. Yeah, we're gonna end soon, but could you have something to offer?
No, I was saying I have to run to practice, but just wanted to, I didn't want to like drop.
Right, okay, all right, okay. Yeah, don't worry. I mean, I will upload it, but we're probably gonna end in a minute anyway. We're running around.
Okay.
Yeah.
And I'll go rewatch that. Thank you.
Okay. Sounds good. Yeah.
Bye.
Bye. All right, we can probably just end here. But the thing is, I do want you to, I mean, think about it. And then, I mean, the slides are up on Moodle, so you will see, like, yeah, we just have a couple of slides left in terms of what you can do, like what you should be doing in the synthesis. I wrote a little function for you, so you can take time to read about it and maybe ask me a question through email or anything, like send a group message. But before we end, let's just like maybe get this sorted out so we know what we're doing. If you read the slide, let's just do that. If you read the function that I wrote here, so I'm saying that suppose we use one set of posterior draws, that is just one of them, like 3, one draw for each, a triplet of beta 0, beta 1, and sigma. So I guess because of the way that I'm saying it, obviously we're using the same, or like we're using a one iteration, given what I'm trying to say. So I guess for just one last minute, can we understand it? Or can we like discuss it to make sure that we can be on the same page in thinking about when we are doing this generation process here, we're using just one iteration and why? So to be clear, we just say 5,000 of them. I agree. So we have to deal with that at some point. So if we're doing what I'm saying that we should be doing, that means for each iteration, so remember the post, that was the data frame, right? We're saying that you're gonna have 5,000, right? Rows, each one corresponds to your iteration, and you're gonna have 3 columns. First one for beta 0, second one for beta 1, third one for sigma. What I'm saying is, well, for a particular, or this is so many different tables here, but this one is talking about the 1,000 observations, and then I'm trying to synthesize this yi. Okay, replace that with yi tilde. So what I'm proposing here is that we are using one slice of this, which is just one iteration. It could be any. We don't like. Let's not worry about which one for now. But like among the 5,000, we're only using one of them. So I have what? I have one value for beta 0, one value for beta 1, and one value for sigma. Right? And then I use the same one for each observations when I'm going down here to generate my synthetic data set. And what that means is I'm using the same beta 0, same beta 1, and the same sigma.
Oh, because you're so pulling.
Yeah, so the thing is, well, if you imagine like we want to use the same iteration when we're generating for every observation. Right? I mean, otherwise there's some other like uncertainty variability going on. What we're trying to capture is at that iteration of your MCMC change, we're picking that one, and then we use the same beta 0, it's a value, beta 0, beta 1, and sigma for every observation. Okay? So that means one iteration can produce one synthetic data set. So with what we have now, we can do what? 5,000 synthetic data sets if I want. Whether we want it, it's a different story. Like we can discuss whether we want to do that many. But the mechanics here is that we're using one iteration to generate one set of synthetic data. So that's why the iteration, or like I didn't write a loop because you can just write a function. I use an index to see which row of the post I want to use. And then I can extract the beta 0 column, the beta 1 column, right? And also the sigma column from there using, oh, yeah, I just made a mistake here. I should have the index as well. Sorry about that. I will correct the code, and then probably the results going to change as well. But at the end of the day, you input. Something happened. So let's just end here today. I don't know. I think, yeah, we're running over time, but let's have you all, read through the rest of the slides. I will assign the paper to read for next time. And also, I hope, even what we have now, you are able to use whatever model that you want on the data, on the CD sample, and generate at least one set of synthetic data. So next time we can.
So you're not just moving on a line. Sorry, the same way just moving on a line.